All right, let's talk about a problem that, if you've ever worked with large language models, you know all too well. It's that struggle to get clean, reliable, structured data out of them. Well, today we're going to look at a feature inside Snowflake that's built to tame that chaos. So, let me just ask you this straight up. Are you tired of playing the AI lottery? You send a prompt, you ask for some structured data, and you just kind of cross your fingers and hope for the best. Yeah, me too. I mean, on the left, that's the dream, right? A perfect, clean JSON object ready to just drop right into your database. But what do we often get? We get this beast on the right. All the information you wanted is in there, sure, but it's buried in a chatty paragraph. And now you have to go write some brittle, painful script to dig it all out. What a headache. And look, this whole unstructured data problem, it's not just a little annoyance. It can be a massive bottleneck for building real AI applications. But this is where Snowflake is stepping in with a really elegant solution to bring some order to this mess. It's a feature that enables structured outputs for the AI complete function. Now, what does that mean? Think of it like a non-negotiable contract with the AI. You give it a very specific JSON schema, a blueprint, and this feature literally checks every single token the model generates to make absolutely sure the final output follows your rules perfectly. So what's the big deal? Well, it means you can pretty much eliminate all of that messy, frustrating post-processing. And that allows you to build data pipelines that aren't just robust, but are actually deterministic. You know exactly what kind of data structure you're going to get back every single time. That's a game changer. Okay, that all sounds great in theory, but, seeing is believing. So let's actually walk through a real-world example and watch it transform a messy customer review into perfect analysis-ready JSON. So here is our input. It's a pretty typical customer review about a pizza place. You can see it's got mixed feelings in there, right? The taste was divine, but it was a tad pricey. It's all just jumbled together in natural language. Our job is to pull this apart cleanly. And here's how we do it. This is the actual SQL query. We're using the standard AI_complete function. But check out that highlighted part, the response format argument. This is where all the magic happens. We're defining our JSON schema right inside the query, telling the model, hey, I want an object back and it must have keys for food quality, cost, and wait time. And here's the result. Just look at that. No parsing, no extra code, no regular expressions, just a clean, perfect JSON object that correctly identified the negative sentiment for cost and the positive sentiment for quality. The model understood our request and had no choice but to follow the structure we gave it. And, the really great thing is, this isn't just for people who live in SQL. You can use these structured outputs directly in Python with the Snowflake ML Python library. You can integrate it with Pydanic models for data validation. You can even call it from the Cortex LLM REST API. It's pretty much available wherever you do your work. So, okay, getting a valid JSON is a huge first step, but getting the right JSON, well, that requires crafting a really good schema. So let's talk about how to build that perfect blueprint for the AI. It really boils down to 3 simple but super powerful keys to a great schema. First, use the required keyword to tell the model which properties are absolutely non-negotiable. Second, provide good, clear descriptions for each field to give the model context. And third, for more complex stuff, you'll want to organize your schema using something called $ref. Yeah, let's zoom in on that last one, $ref, because it's a lifesaver. It's a standard thing in JSON schema that basically lets you follow the don't repeat yourself principle. You can define a common object, like, say, a customer address, one time, and then just reference it anywhere else you need it in your schema. And you can really see the difference it makes here. On the left, you've got this repetitive schema where you're defining an address over and over again. But on the right, using $ref, you get this clean, modular structure. It's not just shorter, it's way easier to read, to maintain, and you're much less likely to make mistakes. Okay, so this feature is obviously incredibly powerful, but to really use it well, it helps to know the rules of engagement. You know how to optimize it, what it costs, and what its current limitations are. For really simple tasks, just providing the schema is usually enough. But as you get into more complex jobs, you can get better, more consistent results by giving the model a little nudge. Just add respond in JSON to your prompt. And for the really tricky reasoning tasks, you'll also want to make sure you're using the most powerful models available, like Claude 3.5 Sonnet, Mistral Art. Now for the big question, what about the cost? Well, the good news is Snowflake doesn't charge you anything extra for the schema validation itself, which is awesome. But you do have to remember that your schema is part of the input prompt. So a bigger, more complex schema means more tokens, which means it will affect your final cost. Just something to keep in mind. And finally, a few quick heads-ups on the current limitations. You can't have spaces in your schema keys, and there are some character limits on property names. Also, that handy $ref feature only works for internal references within your schema, not for pulling in schemas from external URLs. And just be aware that some of the really advanced validation keywords aren't supported just yet. So there you have it, a really powerful way to bring sanity and order to the chaos of LLM outputs and to build rock-solid deterministic data pipelines. So the only real question left is, now that you can get perfectly structured data every time, what are you going to build?